Hi everybody, and welcome back to video number 2 in chapter 18. And when we left off, we were looking at regression as one method of determining total and fixed and variable costs. We'll take a look at that in Appendix 18 Alpha. Truthfully, I will not ask you much on that, as this is more of a statistical technique, which you'll get in your statistics classes. It's commonly used with spreadsheet programs or financial calculators, but the objective, again, is the same, determining total fixed costs and total variable unit costs. All right, if we look at the high-low method in comparison with regression, we find that the fixed cost, which we just calculated using the high-low method, was $14,125, and the variable cost was 25 cents per unit. Had we used regression analysis, we would have had a little bit more in fixed costs and a little bit less in per unit variable costs. Okay. So here we're going to take a look at computing the contribution margin and describing what it reveals about a company's structure. And what is that contribution margin? It's the selling price per unit, often subtracting the variable cost per unit. Okay, that's the contribution margin per unit. We can also have contribution margins where we have revenue minus variable costs. But the contribution margin ratio is going to be the contribution margin per unit divided by the selling price per unit. Or we can do it on a more macro basis, contribution margin divided by sales. So let's look at that. The selling price per unit here is $100. The variable cost per unit is $70. So our contribution margin per unit is $30. And the contribution margin ratio is 30%. The variable cost ratio is 70%, and the selling price ratio would be 100% in that scenario. Okay. Now we'll look at computing the break-even point for a company that has just one product. So let's look at sales level, where total sales equal total costs, resulting in zero income. That can be stated in either units or dollars of sales. So there's 3 methods to find the break-even point. The formula method, the contribution margin income statement, or the cost volume profit chart. Let's look at those. So the formula method, which we will use extensively in our homework, is first of all our break-even point in units. And here we're going to have the fixed costs divided by the contribution margin per unit. So if we are contributing $30 for every unit we make, we can divide that $30 into the fixed costs to determine that we need 800 units to break even, because 800 units times $30 would be $24,000. Sometimes, however, we want to find the break-even point in dollars. And to do that, we again divide fixed costs, but this time by the contribution margin ratio that we just calculated in this slide here. And that gives us $80,000 of sales. Now, because this is selling for $100 per unit, I could have also taken 800 units and multiplied it times $100 revenue per unit and come up with the same $80,000 in sales. Okay, so you want to have those two formulas well understood in your notes. All right, contribution margin income statement. And here we have sales minus variable costs, give us our contribution margin, and then we subtract our fixed costs and we get income. Okay, so in this case, if we look at what we just calculated at break even, we had sales at 800 units at $100 each, 80,000 units. Our variable costs was $70 per unit, and 800 units would mean we had 56,000 of variable costs. And our contribution margin, we could just subtract 56,000 from 80,000, or take 800 units times $30 of contribution margin per unit. That gives me $24,000. Our fixed costs were $24,000, which results in zero income because we are at break even. Okay. Now, here is our cost volume profit chart. And so what we've done here is we have plotted on the green line here total sales. And here on the red line is our variable cost per unit. So what we see here is that our loss area is in the pink and our profit is in the blue. Okay, so at break even, we just calculated the $80,000 and 800 units as our break even point, and you can see it graphically here as shown. Okay, so the changes in estimates. Here, our most likely scenario is that we're going to get $100 for this, and our variable cost will be $70, and our contribution margin will be $30. But maybe we don't. Maybe we only get $96 per unit. Our variable cost a little more than we think it'll be, and that gives us a contribution margin per unit of $24 instead of $30. And our fixed costs are a little more than what we expected at $24,000 at $27,000. So our break-even point in units, given the pessimistic scenario, would be the 27,000 fixed costs here divided by the contribution margin per unit of $24, and that jumps the break-even dramatically up to 1,125 units instead of 800 units. So, as we summarize this, sales price per unit, if it increases, it's going to decrease our break even. But if the sales price decreases, it's going to increase our break even. Same concept with variable costs. If variable costs increase, that increases the break even. If variable cost decreases, it decreases the break even. Same thing with fixed costs. If fixed cost increases, that increases break even. If fixed costs decrease, that decreases break even. And I think you can see that quite easily here with the example they provide. Okay, let's take a look at several applications of cost volume profit. And so here we have a margin of safety. And so here's our expected sales, but here's our break-even sales. And we're going to divide that by our expected sales. So that means that we have basically $20,000 greater than what we expect to break even. So $20,000 as a percentage of our expected sales is 20. And that gives us a level of comfort that we're going to be able to exceed our break-even forecast. Okay, so if we compute income from expected sales, here we have 1,500 units at $100, $150,000. Our $70 variable cost per unit times the 1,500 units. And our contribution margin is 1,500 units at $30. Fixed costs remain the same. So we're going to make $21,000 because we're expecting to sell more than break even. And that will generate income of $21,000. So how do we compute a target income in dollars? We're going to take the fixed costs and divide that by the contribution margin ratio, but we're going to add to the fixed costs our target income. And when we do that, if our contribution margin ratio is 30%, that means we're going to have $120,000 sales if we want to make $12,000 in target income. Okay. Now we can do the same thing with units. Here's our unit sales at target income, and that's going to be the fixed costs divided by the contribution margin per unit. And we're going to add the target income to the fixed cost like we did before. And we're going to divide the sum of $24,000 and $12,000 by the $30 contribution margin per unit. That will generate a 1,200 unit requirement to sell if we want to make $12,000 in targeted income. Okay. So here was the contribution margin income statement, and we work backwards to find our sales. Here, our targeted income was $12,000, and our fixed costs were $24,000. So that means our contribution margin is going to be $36,000. And what we would do is we would take the 36,000 contribution margin and divide it by the contribution margin percent. And that will give us $120,000. The difference then will be $84,000 in variable costs. We could have also taken the 36,000 and divided that by 70%. That's 100% for sales, and 30% for contribution margin would mean the variable costs would be 70%. Okay. So if we're revising our break-even point in dollars, here's our revised fixed costs, our revised contribution margin ratio. That means our revised break-even point in dollars is going to be $75,000. And if we wanted to revise the break-even point in dollars from our original estimate, which was 27,000 of fixed cost goes to 30,000, and a contribution margin of 30% that goes to 40%, that would give us the revised break-even point of 90,000. So our revised margin of safety then, our expected sales minus break-even sales divided by expected sales. Here, we're going to take the 125,000 minus 90,000 here, divided by 125,000. So our margin of safety is 28%. All right. That looks like a good place to stop this video.